In this video, we're going to look at how we actually multiply and divide our complex numbers. So for the first example, we have 2i multiplied by 4 minus 7i. And we're basically going to treat this like you would a monomial times a binomial. So in this case, all we have to do is distribute the 2i. So if we distribute the 2i, we're going to end up with 8i and then a negative 14i squared. And keep in mind, we don't want to leave this as I squared. We want to simplify that so that it really becomes a negative 1. And then negative 14 and negative 1 becomes a positive 14 plus our 8i. And once again, this would be the standard form, a plus bi. So keep in mind, when you're writing your answers, you want to write them in the standard form. Now, what happens if we look at the example of, let's say, 7 minus 2i multiplied by 3 minus 5i? Well, we're going to treat this like multiplying two binomials. And this is where you're probably familiar with using the FOIL method. You're going to multiply the first, the outer, inner, or the last terms. Or you can just think that you're going to use the distributive property twice. In other words, we're going to take the 7 and we're going to multiply that by the 3 and the negative 5. So therefore, we would end up with 21 minus 35i. And then we would distribute the negative 2i, and you would end up with 6i, or negative 6i, plus 10i squared. And now at this point, all we have to do is simplify. We have 21, and we have a negative 35i, a negative 6i, so that's a negative 41i. And then the I squared, remember that is really a negative 1. So that means this would become a negative 10. And then we have a 21. So 21 minus 10 would be a positive 11. And then we have a negative 41i. And there's our standard form. Okay, the next example, we're going to look at what happens if we just have a square root multiplied by another square root. So the square root of a negative 4 multiplied by the square root of a negative 9. Now, make sure that when you're multiplying here with your square roots, we want to simplify the square root first. Do not multiply these together. So the first step is we want to simplify the square root of a negative 4. We know the square root of 4 is equal to 2. And then because of the negative, that's going to be 2i. And then that's going to be multiplied by the square root of 9, which is 3. The square root of the negative, again, is going to be I. So now we have 2i times 3i. So 2 times 3 is 6. I times I is I squared. And again, the I squared is equal to a negative 1. So the answer is a negative 6. So once again here, this example, your answer is just a real number. Now, there's one thing we need to look at. If we have, let's say, 8 minus 10i, a term that you need to be familiar with is the complex conjugate. And your complex conjugate, if we have 8 minus 10i, the complex conjugate would be 8 plus 10i. And over here at the side, I want to look at an example. If I gave you the problem, let's say 4 over 3 minus the square root of 2. Do you remember how you would rationalize the denominator? You would take and you would multiply the numerator and denominator by the conjugate. So 3 minus the square root of 2, your conjugate would be 3 plus the square root of 2. Okay? So this is kind of the same idea. We call this the complex conjugate because we're dealing with a complex number. So over here, what's going to happen if I take the 8 minus 10i and I multiply it by the complex conjugate, 8 plus 10i? Well, Again, we're going to kind of go through using that FOIL method. We're going to distribute the 8. So 8 times 8, we end up with 64. 8 times 10 is 80i. And then we're going to distribute the negative 10i. So we're going to get a negative 80i and then a negative 100i squared. And hopefully it's going to be obvious here. We have a positive 80i minus a negative or minus 80i. So they're going to cancel out. And that should always happen when you multiply by the complex conjugate. Just like over here, when you multiply by the conjugate of 3 minus the square root of 2, 3 plus the square root of 2, that middle term would also cancel out. So now we're left with 64 minus 100, and again the I squared is a negative 1, so really that becomes 64 plus 100. The two negatives make it positive, so 64 plus 100 is 164. And there's one thing I want you to notice. Anytime that you multiply a complex number by its complex conjugate, your answer is always going to be a real number. You will not have an imaginary part. And you're going to see in a little bit here, the advantage of the complex conjugate is to eliminate the imaginary number so that your answer is simply a real answer. Now, be careful with this next example. If you have something like 4 plus 5i squared, well, keep in mind, this doesn't mean you're going to square the 4, you're going to square the 5i. This really means 4 plus 5i multiplied by itself. So that means, again, we're going to have to use the FOIL method. We're going to distribute the 4. So we get 4 times 4 is 16. 4 times 5 is 20i. And then we're going to distribute the 5i. So again, we get 20i. And then 25i squared. Now, instead of these two middle terms canceling out with the complex conjugate, they're actually going to add together, and we're going to get 40i. But once again, the I squared again is a negative 1. So we now have 16 plus a negative 25, and that's going to be equal to a negative 9. And then we have the plus 40i. So there's your complex number. So be very careful. When you square a complex number, you have to think of writing it down twice and foiling it. Or if you use the shortcut where you square the first number, 4 squared is 16, 4 times 4i is 20i, and then you double that to get the 40i, and you square the 5i to get 25i squared. Okay, so there's some examples with multiplication. We now want to look at how do we divide a complex number. For an example, if we have 14 divided by 3i. Now, before I tackle this example, I want to go over here to the side and think about if I gave you 14 over 3 square root of 2, how would we rationalize the denominator? Now, keep in mind, this is 3 square root of 2. 3 times the square root of 2. Well, that means we want to get rid of the square root. Well, we would multiply the numerator and the denominator by the square root of 2, because that means we would then have 14 square root of 2 over square root of 2 times square root of 2 would be 2, so 2 times 3 is 6. So that gets rid of the square root. So over here, we basically want to do the same thing, but now instead of the square root, we have this I in the denominator. So we're going to multiply the numerator and denominator by I, and then we're going to have 14i over 3i squared. And of course, that means we have 14i over 3 times a negative 1. So we end up with 14 over 3, or negative 3i. And of course, I prefer to write it with the negative with the numerator, so we could write that as negative 14 thirds I. In this case, our answer is strictly imaginary. We do not have a real part. So once again, you could technically think of this as 0 minus 14/3 I. All right, now the next example, we have another division problem. We're going to look at 6 minus 7I divided by 1 minus 2I. And once again, we can kind of think of solving this just like we would rationalizing the denominator when we have a square root. So this is where we're going to multiply using the complex conjugate. So we're going to multiply by 1 plus 2I. Okay, and what we're trying to do once again is by multiplying by this conjugate, we're going to eliminate the imaginary part here in the denominator. So if we look at the top, we're going to distribute the 6. So therefore, we're going to get 6 plus 12I. And then if we distribute the negative 7, we're going to get a negative 7I minus 14I squared. Then all of that's going to be over on the bottom. Once again here, we need to distribute the 1. So we're going to end up with 1 plus 2I. And then we're going to distribute the negative 2I. So we would have a negative 2I. And then a negative 4I squared. And once again, in the denominator, we can see the reason for multiplying by this complex conjugate is 2I, negative 2I is going to cancel out. Now, in the numerator, we have 6 plus 12I minus 7I, so that's going to come 5I. And again, the I squared here, keep in mind this I squared is really a negative 1, so therefore negative 1 and negative 14, that becomes a positive 14. And then in the denominator, we have the 1. And once again here, the I squared is really a negative 1. So that's a positive 4. So that means we're going to be left with 6 plus 14 on top. So that's going to give us 20 plus 5I. And then over 1 plus 4 is 5. Now, there's really nothing completely wrong with this answer, but if we want to put it in the standard form of a plus bi, now again, I know this says a plus bi, you could think of it as a minus bi, but we want to split this as 20 over 5 plus 5i over 5, and then 20 over 5 is equal to 4, and the 5's cancel to 1, so you're left with 1i, so the complex number is 4 plus I, so that once again we have a plus bi. So this is our standard form. So really, when you're looking at division with a complex number, we're really just going to, in this case, multiply by the complex conjugate. And once again, we do that so that this middle term with the imaginary part cancels out. And then, of course, because of the I squared, that goes to a negative 1, so that the denominator in this case no longer has an imaginary term.